I'm CK. Tonight we've got another sequencer, this time the 8S from Transient Modules out of Barcelona, Spain. I've done one of their modules in the past. You can find it on my channel. Good product then. This will probably be a great one too. And I hope you enjoy the video. Here's the bag from Transient in Barcelona. Nice paper bag. Very recyclable, of course. We'll open her up and see what we've got inside. I can't even open up a paper bag well. I'm such a spaz. Okay, here is the front panel, and the circuit board looks pretty straightforward. And again, I'm being defeated by another bag, and I don't even know where my scissors went. So I'll grab a X-Acto knife blade, just cut it open. It's about time for me to put another layer of polyurethane on my workbench, so I'm not worried about scratching it up. So it's an 8-step sequencer. So we can see 1, 2, 3, 4, 5, 6, 7, 8. I believe those are the pots, these 100K pots that you can see on the circuit board that will be setting the note value. And that looks like clock in, reset, hold, which is interesting, random, direction, assuming of course that it reverses direction, and the output. So pretty straightforward. Board looks good. The pots, the jacks, there's a pin header there. Oh, it looks like we got one little surface mount part here, a CD4051. I'll look that up in a little bit. And pin headers to connect the boards there too. And that's a 1K RLEDs. I'm not sure what that is. I'll have to find that out. The board looks good. It's got all through-hole plating. I'm getting a phone call. Let me see what the phone call is from. It's from a number I don't recognize, so I'm not going to answer it. Go away. And on the back board, power connector. Oops, it's upside down. Power connector looks like it's keyed. 2 ferrites, a couple of diodes. They're Transient and Bafaco are the ones who most often use, in my experience, use ferrite beads. Some caps, some resistors, transistors, 072 op amp, DG4080J, and then an Atmel Mega microprocessor. And then these are 2 other thingies. I don't know what they are. Could be. No, I'm not even going to speculate. So that's the boards themselves. Oh, we've got... Oh, I see. This may be external entry points, or... I'm sorry, not external entry points. They're probably jumpers for bipolar, unipolar, hold 1, hold 2. But again, we'll get the real answers as we go through all this. So we'll put those in that bag over here. Got another bag. Inside we also have power connector, power cable. Looks fine. Set the bag over for recycling. Now we'll see what parts are in here. We already know there's 3 standard ICs and 1 surface mount IC. So let's see what else we got. First we'll pull out the foam with the ICs on it. These are the socketed ones. So yeah, that's an Atmel AT Mega microprocessor. I assume it's already programmed. And the DG408DJ, not 4080. Again, I'll look that up in a little bit. Here are our transistors. A sticker, I already have one of theirs, but always good to have stickers. Resistors. More resistors. Pots. A couple of diodes. Oh no, these are the ferrites. So we're not making a ferrite bead. These are already pre-installed. So I don't have to worry about saving any resistor leads to put on the ferrite beads. LEDs, I assume we're going to have 8 of those. And this is that header that goes back on... Which board does this go on? It actually goes on the pot board. Oh, and it does mate with the other board. Okay. Looks like that's soldered on. Okay. I'll just dump all this stuff out and make sure there's nothing left in the bag. What else we got? Jacks, pin headers. Looks like they've already cut the pin headers to the right length, or they bought them the right length, which I appreciate. There's the diodes. Now what I'm not seeing, oh there it is. Here's the surface mount processor of some type or other. Nothing too particular interesting. Also, just to point out, very user-friendly, they've already taken the panel nuts off the jacks, which I appreciate. One trimmer, a spacer. So this is a stand-up trimmer, so you can get at it from the side. Let's see where it goes. It'll go right here. So you can do whatever adjustment you need, and I'm not sure what we'd be adjusting there. Now one thing you might have noticed that we didn't see, and yeah, I was right, here are the jumpers we're going to put on the, I'm sure there's some 90 degree, yeah, so 90 degree pin headers, which will go in here, and then you'll jump them for bipolar, unipolar, and hold 1 and hold 2. I'm not sure what the difference between hold 1 and hold 2 is, but we'll find out. Now, one thing you don't see is you don't see a build guide or a URL to a build guide, so I will go look it up on their website and see what they've got, and also look up some of these chips so we can see what they all are. I'll be back with the soldering iron heated up and some information about these chips in a little bit. So the two chips that we were interested in, the DG408DJ and the surface mount component, the CD4051, are both multiplexer, demultiplexer, and analog to digital devices, so that's what they're about. Now we're going to do the surface mount component first, and this one looks pretty easy as hand doing surface mount is. The pads are far enough apart that I don't expect I'm going to have to slap a lot of flux on the board, which will be good. I will be using my MG Chemicals 0.025 inch diameter, the thinnest solder I typically use, and I only use it for surface mount components. That's not quite true. I use it for some other things too, but it's what I do always use for surface mount. Now, let me get my surface mount tweezers out. Make sure they're clean. I think I cleaned them. You always got to make sure your surface mount tweezers are clean, because as you work they'll collect a little of the rosin flux, and you have to, and then they will pick up parts when you don't want parts to pick up, because the rosin can be a little sticky, and it can be really frustrating to be putting a surface mount resistor down and you lift your tweezers and the resistor hops off because it's stuck to the tweezers. So periodically need to wipe them off or take a little isopropyl alcohol and get the flux off them. So we'll open the package, put it on the solder pad. And by the way, just in case you were interested, this solder pad is one I made from 2-part high temperature silicon rubber I got from Amazon, and very easy to do. I have a video on that also. Now this is a TI part, so the notch is shown right here, and there's a stripe on the chip there, which I'm going to assume is going to be like a notch. I hope I'm getting it right. One thing, I did go to Transient Modules website to look for the build guide, and I clicked on the build guide link, and the website says, oh, there's no document there. So they need to update that. I'll send them a note on that after I get done here this evening. I'm going to zoom in a little bit here so you can see more closely what I'm doing when I'm surface mount prepping, and hopefully I won't go out of frame or get my big fat head in the frame, which often happens when I'm doing surface mount because I come in and need to look straight down and get my head in it. But I'll try not to do that tonight. So the first thing I'm going to do is I'm going to prep one solder pad with a little solder, like so. Now I'm going to rotate around like this. Hopefully I'm still in the shot, and I still am in the shot. Now I'm going to take the chip, and hopefully it's not sloped on the side, and it is not. Get the legs lined up so they're good on both sides. Oops, my tweezer slipped. So they're good on both sides, and I've got lots of space. And I'm going to reheat that little solder dab I put down there, and the leg sinks into it, and I wait, and now the chip is secured. Very simple. Now we'll do these legs, and you can see my personal technique. Sometimes, if these were tighter pitched, I'd rub my solder paste in there so I don't bleed solder between the legs, but I don't think I'm going to need to do that here. There's plenty of space, so I put the soldering iron right next to that leg. Give it a little solder, and it shifted a little bit, but it didn't go too far. So that leg's done. That's those legs. Let me take a real close look at them to make sure I've got a good solder joint on all of them, and I don't think I do on the two at the beginning. I didn't get quite enough in there, so we'll go in there and just heat it up again. And that's all the pins, and as you can see, I didn't have any trouble bleeding across. And they all look good. Now I'm going to go a little bit, makes the video a little longer, but don't care, because I think this is important. I'm going to take my meter, because you really can't tell. With a surface mount, it's a lot harder to tell if you've got a good joint versus through hole. So I'm going to probe these to see if I'm actually making good contact from the pad to the chip. So I'm going to touch the outside of the pad and the chip leg. That's good. It's good. So that's it for the surface mount part of the build. quick and easy. Now we're going to do the resistors and the diodes and the ferrite beads. Not a lot of any of them. This is not a very complex kit because so much of the work is being done by the ICs that there's not a lot of analog. The output signal path is analog, but there's not a lot of components to it. The output, he says the output path is analog, but if you've got the 072s in there, that's not really technically all analog. And again, we don't have a build guide, but since all the component locations are marked, then we don't need one. The only thing that, again, on the bipolar and unipolar, they're jumpers to go from -5 to +5 or 0 to positive 10 volts. So you can make that choice depending on how your rig actually works. So we'll do the 100K resistors first, 6 of them, and I'll do one live just so we can see how this board reacts to solder. It probably reacts really well. And we also do the first interesting thing, which is saying how close can you bend the leads to the body of the resistor. And in this case, you want to bend them as close to the body of the resistor as you can. I'm going to go back to my standard solder size, my 3/2 size for this. Okay, solder flows really well. Goes right down into, wicks right down into those holes, and you can see good connection. So that's good. I'm going to trim these leads. So there's not much more to say about resistors. And for the diodes, the marking on where the positive side, on where the cathode side is really clear, the stripe side. The ferrite beads are not polarized either, so they can go any old which way. So with that, it's resistor time. So all the resistors, diodes, and ferrites are on the board. Now I realized what this one's for. This resistor that says RLEDs it's in series with all the LEDs to have a little current limiting. He just uses one for all the LEDs, which is an interesting thing to do. Now we'll do the transistors. There's 1 here and 4 here, and there's 4 on this strip and 1 floating loose. And since I don't have a build guide and these are not labeled with their part numbers, I'm going to make the assumption that these 1, 2, 3, 4 are these 1, 2, 3, 4, 5, and that screws me up completely right there. There are 5 of those, so that must be the 5th one, because this is a 7905 and this is a, gotta look at it, well, it's a 79L05. So this one goes here. So he only added the part number for the one transistor that's different, which is fine. And as always, make sure the flat spot on the transistor points to the flat spot on the circuit board markings. I'm not going to call it silk screening anymore because I don't think anybody silk screens anything. Where's my nippers? I don't fight components out of the paper tape that they're intended to be used on machines with. because it just bends pins and all that. I just clip them off. Now I'm going to put the IC sockets on the board. And the best way I like to do this, or the way I like to do this, is I rest the socket on my pinky finger and solder one leg in, let it cool, make sure that all the legs are through and the socket is flat to the board. Then do the next one just like that. Now we'll put the condensers, that just shows that I'm old, capacitors on the board. Now, next thing we have here, which we don't often have on these boards, where did I put it? We have a 16 megahertz crystal. It's going to drop in here next to the microprocessor. Crystals are also not polarized, so don't worry about putting them in backwards or something like that. Anyway, it'll be fine for them. And we've got two, oh, look at this. We have an LM78L. So this is a voltage regulator, so it probably goes here since that's near the power connector. And that's just always a safe assumption. We'll put the power connector on also. And it's a 90-degree one, so it's actually a little easier to get straight than other types, but again, same thing. Put one pin down. It's not quite flat, so press on it with my fingers behind the board. Now it goes flat. Now that's all. Well, let me put these two 90-degrees on here. Yeah, the one thing that I don't know, I still don't know what hold 1 and the jumpers for hold 1 and hold 2 are, since the build manual and there's no user guide, so I'll have to figure that out later once we get it up and running. So that, besides the pin headers, that's all we've got on this board, and I'm going to stop for tonight because the cats want to get fed. So two things. First, that other 104 goes on this board on the controls and pots board. I hadn't noticed it. I hadn't looked on the back of that board, so wasn't aware of it. So no extra parts this trip. And the other more important thing is I went to their website again, and the build guide is up today. So that's all good. And it's a good one. Got lots and lots of pictures. Pictures for every step, which is always good. And yeah, we did put the surface mount chip on the correct way. So everything is good. Now the next thing is to put our pin headers on. Okay, so the 8-pin header goes first on this board. But main thing is this board is now complete. Now I will go ahead and socket the ICs. Little circle to the notch. And there we go. Now that board is all done, modulo making that connection when we put everything else together. Oh, and there's the, I'm sorry, I missed that. The 24-pin connector goes, I mean the 2x8 pin. What do you mean 24-pin? I don't know what the heck I'm talking about there. Get some more solder. Okay, after we've got those pin headers on, it's time to put one of the spacers on. There are 2 spacers. There's 1 and 2. And we're going to take the 11mm one, which is slightly bigger, and we will put that on that little screw. Get my screwdriver out of my ready rack, and it goes next, goes right here. Now if I were a gigging musician, I would probably put a little Loctite or other thread security material on there, but since I just have this in my studio, I don't care about thread security. It's not going anywhere. Now we will populate all the pots, and they're all the same values. They're all 100K. And the support legs are a little splayed out. I'll tuck them in a little bit. And just as a procedural thing, I always put pots on first because the support legs have that little kink that holds them in place. And what that means is they jar the board a little bit when you put them in place. And if you have the jacks, some jacks already set, you'll pop the jacks out when that jams against the board. I learned that a number of times before I finally said, well, just put the pots on first, you dope. There we go. Now we can lay the front panel on top. Actually, there's another spacer here. That goes on the front. So I'm going to lay this on its side right here, and I'm going to take the spacer, which takes this little Allen heady type screw and goes right in here to support. And I like that because since these pots have no panel nuts, this would be a little floppy if we didn't have this supporting thing. And where did I just put the screw? There it is. So This gives a little bit more support to the pot panel, and I like that quite a bit. Very thoughtful addition. And I don't have that Allen wrench size right with me right now, and I'm not going to go to my toolbox and get it, so I'm just going to crank it down that way, and that looks good. Now we'll drop this on. I'm not going to do the LEDs positioning yet, because that'll come after we get everything else stabilized here. Got to fight all the knobs into the positions they need to be in. There we go, and now get the jacks in the positions they need to be in. Take my little pokey thing and do some adjustment. Now the next thing I'm going to do, while I'm holding this right here, I'm holding it kind of tightly. I'm going to take a little solder and lock this pin on this jack down and put its panel nut on, and then put this screw on that front panel spacer in place. So now everything's tight. I'm not still not going to do the LEDs quite yet, but I'm going to solder all. I'm going to drop all the LEDs through their little holes now. Set this on down and solder up all these connections, and we'll do that in fast motion. And everything is soldered together. I'm ready to put the module, the back board to the front board. Now I did two things off camera. I plugged the power cable in, and it's keyed so you can't get that wrong. And I also put the jumpers on, and I'm going unipolar for 0 to 5 volts instead of bipolar. And for the hold adjusts the hold behavior. When you bring it high, it'll hold it, but you can either advance and still hold if you get a clock signal or not, but that's not important to me, so I'm just have it in the regular hold. One other thing, the pot, the trimmer, is primarily for if you're working with a digital receiver of this. Since I'm just doing straight analog, I'm not worried about that. So I turned it all the way clockwise as he describes. Now we'll go ahead and mate the boards. Make sure all the pins went in, Oh, he is also one thing that is in the user's manual, or the build guide, I'm sorry. The two voltage regulators are very similar in part numbers, and he emphasizes make sure you put the right one in the right spot or things will catch on fire, which we don't really want. So this is it. Here's the front, the side, the back, the other side, the top, and the bottom. Now we'll put it in the rack and see how she sounds. Let's power it up, see if anything blows up. Nope, nothing blew up. No chance to laugh at me today, lads and lassies. So I've got my sequencer providing my Division 6 is going to provide the clock signal. So I've just turned it on, and you can see it rotating around here. Let me turn the volume up. Oh, I see what we're doing. I'm wrong. I need to go into that CV out to an oscillator. Okay, now so that's what it does, basically. I'm going to take my trigger, my MIDI trigger, and go into random here and see what happens there. So as you can see, when I hold the gate down, watch the LEDs. It'll randomly pick where it's going, which is nice. Has a little variety that you can throw in. Let's go into hold. So that makes sense. Let's go into the direction, and I'll trigger that. It only goes random. It only reverses while that gate is high. So you have to hold it down. So that's kind of nice. I don't know what reset's going to do here. Maybe it'll set it back to step 1. Yeah, so it acts kind of like a combined reset and hold, because as I take it high, it'll go back to 1 and then hold until I release reset. I'm going to try one other thing here, because this might be interesting. I'm going to go back to hold, and now I'm going to hold on 1. So you can hold, while you're holding the note, you can also change the CV value. I'm going to do, just for fun, I'm going to take this out of hold. I'm going to put my this LFO I got running, I'm going to put that into direction, just cause. Now the LFO is going fast, so it's toggling it direction quickly. But see, with a slower LFO rate, you can make it automatically go back and forth. Let me go a little faster. So you can use the LFO to trigger direction reversal, so you don't have to constantly be messing with it. Let's see what the LFO does to random. I'm going to take the LFO rate way down. Well, that's pretty interesting. So as you can see, there's a lot you can do with this module. It's pretty straightforward. Set your note values to whatever. You may even want to tune it, even though if you're tuning stuff, I'm not sure that you're really into eurorack if you want things in tune, for crying out loud. I'm going to speed up the clock signal to see how fast we can get this thing to go. Pretty fast, and you might have noticed I was still getting discrete notes when I was at the fastest I could go with my sequencer. Instead of it blurring, you could actually sense discrete notes. So, nice little module from Transient Modules. They're 8S, as you saw, except for the one surface mount part, which is not that hard to put in. Obviously, there are some boards that you can train yourself on surface mount soldering. I've got some on my channel. I'll link one in the description so you can buy one of those for like 10 bucks from Amazon and practice your surface mount soldering on something that you don't care whether you blow it up or not, because it costs like $10. And the controls are really nice. Overall, a very nice unit. Hope you enjoyed the video.